Welcome to the web lecture for Chapter 12, Quasi-Experimental and Survey Designs. That would be Chapter 12 in the first edition, Chapter 13 in the second edition. So quasi-experiments are similar to the experimental designs that we've discussed so far. The difference is that with true experiments, we're able to randomly assign people to conditions. With quasi-experiments, we're using existing groups or groups that are not randomly assigned. So it's obviously impossible to manipulate people into different gender groups or ethnic backgrounds or socioeconomic backgrounds, or sometimes we have pre-existing groups like public versus private schools, or people with depression, without depression. We can't randomly assign someone to be depressed or not. And we still want to do experiments with these kinds of groups. But because we don't have random assignment, we call these quasi-experiments. We'll talk about non-equivalent groups designs, and then we'll go through and we'll talk about longitudinal and interrupted time series designs. So in a true experiment, right, we want our groups to be equal. But when we have a quasi-experimental design where we have existing groups, it's not entirely certain whether those two groups are equal. They may not necessarily be equivalent on some of those extraneous variables. I recall for experimental manipulations, or recall for random assignment to groups, random assignment equalizes those extraneous variables across our two groups. And we have non-equivalent groups. We can't guarantee that the groups are going to be equal on all of those variables at the beginning of the study. So we have to be careful to try and identify and control for any of those potential confounding variables that may serve as alternative explanations for differences we see between the groups once we implement our treatment and our dependent measures. So for example, let's say you have a new after-school program that's going to improve academic performance. The principal allows students to sign up for the program and then measures the academic achievement of the students who complete the program compared to those who do not complete the program. And let's say that the experimental group scored significantly higher on the achievement test than the control group. This is a non-equivalent groups design because the groups are not randomly assigned, right? And in fact, the way that the groups were set up leads to a confound, and that is the groups contain different kinds of people. The kids who chose to participate in the after-school program compared to those who chose not to. It could be that the kids who chose to participate had a different level of motivation than the kids who chose not to. And that different level of motivation is what's causing the difference in academic achievement that we see at the end of the program, not the program necessarily itself. It creates this confound. And we call this a selection effect. And we talked about this in the previous two chapters, and we're talking about it here in terms of non-equivalency of groups. So for example, if you asked, are people responsible for climate change, and you asked in an Earth First rally, you're going to get a very different answer or selection than if you ask at an NRA rally, right? Because these two groups have very different ideas about this, and this would represent, again, a selection bias, non-equivalent groups. So there are other kinds of options we can use when we study quasi-independent variables. Longitudinal designs are when we follow the same sample of individuals at different points in time. So we measure again at time 1, measure at time 2, time 3, and what we can look at is how people change over time. This is a within participants design, and you get good temporal precedence, right? So if I can see, if I'm tracking your academic achievement over 8 years, I can see how that achievement is changing over 8 years. And I can't necessarily infer causality, though, unless I have a control group. So, for example, Huesman et al. 2003 looked at longitudinal relations between TV viewing violence and adult aggressive behavior. So they measured the amount of violent television that kids are watching. This is again in 1970, where they started in 1977, I think. And they classified them into low, medium, and high levels of violent television that they watched between the ages of 6 and 10. And then they followed up with them 15 years later, and they measured aggressive behavior in terms of the number of times that people were arrested, the number of times that some of these children got into fights, these sorts of things. And what they found was that in 1992, the children who had been watching high levels of violent TV in the 70s tended to have higher levels of aggressive behavior and behavior problems in adults 15 years later. But there are some confounds, right? This is a quasi-experimental design because they are not randomly assigning people to conditions. They're using those existing groups. Right? And it could be that something about the kids themselves who choose to watch violent TV is what's causing that aggressive behavior. It's not that the violent TV causes aggression, but that people who like to watch violent television are also people who just happen to be more aggressive. And so without a control group, we really can't rule out that confound. Without random assignment, we can't really rule out that confound. But we do get a good picture of how these things change over time. There are other problems with longitudinal surveys. So attrition, this is when you lose a lot of people in your study. And the question then becomes, are the people who dropped out of the study somehow different from the people who stayed in the study? You also have reactivity. People want to be consistent over time, and so they might change their answers to try and maintain that consistency. And without a manipulation or without an experimental, without randomly assigning people to groups, it makes it very difficult for longitudinal designs to tell people, to explain why things happen over time, right? So there's a classic developmental psychology research that looks at impulse control. And so they bring kids into the lab and they set down a packet of M&Ms on the table or some kind of treat, and they say to the kid, these are 5 or 6 year old kids, and they say, here's what I'm going to do. I'm going to leave this packet of M&Ms right here, and you can totally eat this packet of M&Ms. But when I come back in 10 minutes, if you don't eat it, I will give you 2 packs of M&Ms. So there's this incentive for these kids to have impulse control and wait for the better deal with more M&Ms. Now what they find is that kids at 6 and 7 who have really good impulse control, who can wait out that 10 minutes to get that second pack of M&Ms, actually end up having a whole host of other life success relative to kids with low impulse control. So those kids with impulse control are, have better jobs and get better educations and these sorts of things. Now, again, this is longitudinal. We can show that this is the case, that this predicts future behavior, but we can't necessarily say why unless we have some kind of experimental manipulation. The last one we'll talk about is interrupted time series. So in order to explain a quasi-experimental design, I really have to draw a picture of what this kind of data will look like. So I'm just going to hop over to Microsoft Paint here real quick. There we go. So with an interrupted time series design, the way to imagine this is we've got some value that we're measuring over time. So you can think this y-axis right here measures the dropout rate in high school, and the x-axis measures time, okay? And this is different years. So this might be 2002, 2003, 2004, 2005, 2006, okay? Now, what we do in an interrupted time series design is we measure our dependent variable over time for a period of time before we introduce our experimental manipulation. So let's say we're interested in reducing high school dropout rates, and we'd like to do an intervention that we think is going to reduce dropouts. So what we do is, for the first few years, we measure the dropout rate. And let's say that for the first few years, the dropout rate looks something like this. Then right here, oh, I want to rotate you. Why don't you want to be rotated? Okay, well, so right here, in this year, let's say this is the year where we implement our experimental manipulation. We give the program to reduce dropout rates to all the schools in our district. And then what we do is we're able to measure the dropout rate subsequently. And let's say we add this. My brushes are all kind of weird here. Here we go. And we have another data point here. So this is 2002, 3, 4. Isn't it fun to watch me play Microsoft Paint? 5, 6, and 7. So if we implement our program change here, and we can look at the pattern before the change and compare it to the pattern after the change, right? This allows us to infer causality, to say that, well, all else being equal, the only difference between these few years here and these few years here is the implementation of this program. And so what we can say is then the implementation of this program is what's causing this change in the trend, or this change in the pattern, right? The trend had been increasing, and and now the trend is decreasing following our intervention. And this is why we call this an interrupted time series, right? We have a series of time, we interrupt it with our program, with our change, with our experimental manipulation, and then we have a decrease. And then we measure that time, measure the effects subsequently. So an interrupted time series is pretty cool. It gets around some ethical problems, right? If we have intervention that's going to help kids not drop out of school, right? It would be kind of unethical to have a control group where we withhold that intervention from some kids. So by using the multiple time period pre-post design, this interrupted time series, we can compare the time, the trend before the program to the trend after the program, and that way everyone can get this experimental manipulation, this potential benefit. So that's interrupted time series. Briefly, we're going to talk about surveys, mostly because this is the week where you will start working with your group to design a study for your final project, final thesis. So surveys describe attitudes. Oftentimes we use questionnaires. Ideally, the samples that we get represent the population. Right, we've talked about this idea already in this class, so I'm just going to sort of gloss over some of this. Ideally, we take the sample from the population and we want to generalize the results of our sample to the larger population. So when Gallup does a national poll asking about how people thought the presidential candidates handled themselves in the debate, or how people feel about particular policies, what they want to be able to do is generalize the responses from that sample to the American population on the whole. So when you have a representative sample, then ideally your sample should look like your population. So if you have 75% white, 15% Hispanic, 12% African American in your population, then your sample should reflect that same ethnic breakdown. It should reflect the same gender breakdown and the same education breakdown, and all of sort of the demographic variables of interest. And if that happens, then your sample is representative of the population. Now, there's a couple ways you can do this. You can do probability sampling, which means that everyone has an equal chance of being included in the study. The way that we do this practically is what we call random digit dialing. So there are computers that will randomly dial phone numbers until someone picks up, and then they connect that person to the survey taker, the survey administrator. This is a good way to get a representative sample. If we do this 3,000 people, we randomly call 3,000 people in the United States, chances are that sample of people is going to look a lot like the population of people in the United States. Now, because this approach relies on randomness, it is really good, but sometimes you miss groups or characteristics that are underrepresented in the population. Right? So if there's a very tiny, tiny proportion of the population that makes up a particular demographic, you may miss those people altogether just because they represent such a small portion of the population. You can imagine if you have a group in the United States that represents a half a percentage of the population, and you want a half a percentage in your sample of 3,000 people, well, that means you need to get 10 of those people or something like this. And so you may miss those people through probability sampling. The way we get around this is what we call stratified random sampling. So this is when you divide the population up into the individual subpopulations you're interested in, and then you randomly select people from within those subpopulations. So for example, if we're interested in making sure that we have a representative sample of gender at Chicago State, we could start with the entire Chicago State population, break them up into males and females, and then sample 63% from the female group and 31.5% from the male group. And then that way we can guarantee that our sample is going to be representing both of these groups appropriately. Stratified random sampling does increase representativeness, but it is also much more expensive to do than probability sampling. Now, the other approach is what we call non-probability sampling or convenience sampling, which is basically you just get who you get because it's easy to get them. This is what you are going to do for your project, right? There is no guarantee that each member has an equal chance of being in the sample. It's not systematic, right? So it's just whoever of my Facebook friends is willing to fill out my survey for my final project. Whoever, TV news does this all the time. Text blah, blah, blah now if you agree, or text blah, blah, blah if you don't agree. It's like, well, that's a convenient sample of all the people who are watching that show at that moment who have a text message capability on their phone and care about this opinion, right? So it's not really representative of anybody except that group of people who is watching that show with the ability to send a text message. A bias sample occurs when the characteristics of the sample are systematically different from the target population. So for example, we talked about this already, but in the United States in psychology, the predominantly in the 1950s, 60s, and 70s, research subjects in psychological research were straight white males. And straight white males, as we all know, don't necessarily represent the entire population of the United States. Now, if we're talking about how neurons work, if we're talking about really basic psychological, biological processes, then this might not be a big deal. But if we're talking about something like prejudice or pro-social behavior, which may have cultural components, then this is a problem because our studies are underrepresenting large sections of the population. Now, this is a problem in psychology that psychologists are aware of. However, it has gotten better as the level of diversity in colleges and universities around the country has improved over the last, I'd say, 20 or so years. But it is still a problem that we should be aware of. One thing to know about research, survey research, is that it is possible for you to do an experiment using surveys alone. And one way you can do this is by manipulating the instructions to create experimental conditions. So for example, you could have people get one version of the survey where they write about a time when they were rejected by a group of people, and you can have another group of people write about a time when they were accepted. So half of your participants get the rejection, half of your participants get the acceptance writing task. And then you can measure maybe how that affects mood, or as we talked about a couple weeks ago, how that affects the temperature of the room, their perception of the temperature of the room. Okay. And again, you can do this in a survey by just changing the instructions. So half of your participants get one set of instructions, half of your participants get another. You can manipulate the ordering of questions, so you put the demographic questions first or last. If maybe you think thinking about your basic demographics might have an effect on your independent or might have an effect on your dependent variable, you can manipulate whether they say that first or last and see how that affects your dependent variable. I did a study where I was interested in manipulating relative social status, and I showed participants a picture of a ladder, And I said, think of this ladder as representing where people stand in the United States. The people at the top of the ladder have the best jobs, the most money, the most respect. The people at the bottom of the ladder have the worst jobs, the least money, and the least respect. And then what the manipulation was, for half of the participants, I said, compare yourself to the people at the top of the ladder. Think about how you're doing relative to the people with the best jobs, the most money. The other half of the participants said, think about how you're doing relative to the people at the bottom of the ladder. Right? And just by changing people's frame of reference, you can make them feel like relatively higher or lower status. Right? Me as a straight white male university professor, right? I am not in the 1%. I clearly am doing much worse than Mitt Romney. I don't have multiple houses and jet skis and boats and whatever. So when I think about myself relative to them, I think of myself relatively lower social status. But if I think about myself relative to someone who's homeless, I might feel that status a little bit differently. And again, all of this was achieved just by changing the instructions, by changing the survey. So when you are working on designing a study for your senior thesis, remember this is an option that you have available to you. Now, when we do survey research, a lot of times we use questionnaires, ask self-report measures. Most of you will be doing this. The one thing that I always say is when you are building a questionnaire, the best thing to do is use someone's existing questionnaire. You should avoid at all costs writing your own survey questions. It is not easy to do, right? The best solution is to Google for the aggression questionnaire or depression survey or anxiety measure, stress measure. And what you want to find is an existing questionnaire survey measure that you can cite. You can say, well, we measured aggression using the Bus-Perry aggression questionnaire. And then in your references section, you would just cite Bus-Perry 1999 or 1998, I think it is. Okay. It is always better to use a measure that's shown to be reliable and valid in previous research. Okay. You can create your own items, but I discourage you from doing that because it's just such a huge pain, right? If you are going to choose to create your own items, you generally want to make sure you avoid free response questions. So open-ended questions where people are just writing whatever they're going to write. That can be really informative, but it's really difficult to code, right? There's not much we can do with that. Closed responses are better, but you always want to make sure you incorporate some amount of variability, right? Think back to when we talked about floor effects and ceiling effects last week, right? You want to make sure you leave enough room for variability so that you capture the variable that you're interested in, right? If you ask people, do you smoke, yes or no, right? People who smoke, who consider themselves smokers might say yes. People who don't consider themselves smokers might say no. But someone who smokes one cigarette every month or so might not consider themselves a smoker, right? And so they would get lumped into the no category, even though they do sort of smoke. So you want to make sure you're using multiple choice responses. Strongly agree to strongly disagree on a 5-point or 7-point scale. Okay. Other things to avoid as you are thinking about your questionnaire: avoid double-barreled questions where you are asking more than one thing at a time in one question. Do you think employees should be given more flexibility and less supervision? If someone says strongly agree to the statement, what are they agreeing to? Are they agreeing to flexibility or supervision or both? Right? You don't really know. And so typically what you want to do is you want to break that up into 2 questions. Do you think employees should be given more flexibility? Strongly agree, strongly disagree. Do you think that people should be given less supervision, as a separate question? You want to avoid leading questions where there's an obvious answer. Right? Should bad employees who are always late receive a reduction in pay? Well, like, clearly there is a right answer there, right? So you should avoid leading questions because that makes for biased survey data. Typically, you want to put the most interesting questions first. There's participant fatigue is when the participants just get tired of doing the survey over time. This shouldn't be a problem for your projects because your project should only be, about 15 to 20 minutes for our participants to take. But you do want to make sure that you put the most interesting things first, so the things that you're most interested in first. You can use funnel questions, right? So if you're only interested in people who are parents, you might have a question that says, are you a parent, yes or no, at the beginning? And if they say no, they say, if no, skip to question 35, and then have them skip all that stuff that's unrelated to them. One last thing to be aware of is that we did talk about this idea of reactivity, that because it's self-report, people may not be truthfully responding. One way we can measure the truthiness of their responding is with social desirability, right? Measuring social desirability is people's tendency to report or respond in the way that they think they should respond, or the way that they think they're expected to respond. So we can measure this using the social desirability scale. And here's some examples here. No matter who I'm talking to, I'm always a good listener. Definitely true. Of course I'm always a good listener. I like to gossip at times. Oh, false. I never gossip. Right? Clearly the truthful answer here is, no, I'm not always a good listener. And true, yeah, I do like to gossip at times. Right? But if someone is trying to present themselves in a socially desirable manner, they're going to give the socially desirable, not true response, right? I have never felt the urge to tell someone off. Oh, that's very true. I'm a very good person. When, like, really, it's false. And so we can use this scale to measure the degree to which people are responding in a socially desirable manner when they're taking our surveys. And if someone is scoring really high on this Marlowe-Crown social desirability scale, that means that we can't necessarily trust their responses to some of our other survey questions. So that is it for the web lecture this week. Make sure you take a look at the web lecture for the draft method section guide, and then make sure that you meet with your group between now and next week and start brainstorming ideas for study design for your final project.